Hello everyone. Okay, this video, I'm going to show you another example for elastic collision. Okay, here is problem. This problem is much easier to solve than previous one in elastic collision. Okay, next one is difficult. Okay, so here is the elastic collision problem. Okay, suppose we have two objects M1 and M2 and it gives you a mass. M1 is 1.6 kilogram, M2 is 2.1 kilogram. And M2 now M2 attach a spring, and its force constant is 6,600 Newton per meter. And then moving in opposite direction and give you initial velocity, and they will make a collision to each other, of course, because they moving in opposite direction. Sorry, not yeah, yeah, one is to the right, the other is to the left, so they will make a collision. And we assume the collision is elastic. Okay, so the first problem, find the velocities of the two objects when they are again moving separately after the collision. Okay, so these two objects, they have spring. Okay, so but like I said, in collision, we don't care we don't care about the detail of the force. Even if right now we tell you, you have spring, and when they collide to each other, the spring will compress, and then after the collision, and then they was moving separately. Okay, yeah, it's a spring force right now, but what I said before, during the collision, we don't need to know any detail of this force. So the spring here, yeah, that doesn't tell you, that doesn't matter. Okay, that doesn't affect we analyze our 1D collision problem. Okay, so okay, let's answer the first problem. Find the velocity of two blocks after the collision. Okay, of course, right now we assume it's elastic collision. And yeah, we ignore the we just ignore the spring here. Yeah, it doesn't matter. It doesn't make any effect here. Okay, because during the collision, yeah, we don't have to know the detail of the collision force. So okay, first problem. What's the velocity of M1 F2 after elastic collision? Okay, for the elastic collision, okay, our analyze tool is okay. What is our analyze tool? Okay, so let's just A problem. Okay, it's A problem. It's a B problem. Okay, so let's see the A problem. Okay, in the elastic collision problem, what's the analyze tool we have? Momentum conservation. Momentum conservation. Because the system is isolated. Once the system is isolated, the momentum always conserved. Okay, that's very important and very vital concept in physics. Once the system is isolated, the momentum always conserved. Okay, and also we don't have any detailed internal forces. And what about two kinetic energy conservation? Kinetic energy conservation because okay, so okay, what else? So the last one is V1 minus V2 is equal to V1 prime minus V2 prime. That's our analyzed tool for elastic collision. Yet I like these two. Okay, I like these two. Momentum conservation. Okay, you must use the momentum conservation. Okay, we definitely have to use. And the other, I like to pick this one, okay, because these two, like I said before, this is the first order equation, much easier to solve. I wrote this is wrong. Okay, B2 prime minus B1 prime. B2 prime minus B1 prime. Okay, yeah, for this problem, I'll use these two, momentum conservation and B1 minus B2 equal to V2 prime minus V1. Yeah, you can try you can try use kinetic energy conservation to solve the problem. The answer will be the same, but that's where you have to do more algebra work. Okay, so Okay, what's the momentum conservation? Momentum conservation is the total momentum before the collision equal to the total momentum after the collision. Okay, so what's the momentum before the collision? Okay, the momentum before the collision is m1 v1 plus m2 v2. Okay, m1 v1, m1, yeah, m1 is how many kilogram? 1.6. Remember? Oh, 1.6, 2.1. Okay, so I miss his here. M1, 1.6 kilogram. M2, 2.1 kilogram. Okay, so it's 1.6 times 4 plus 2.1, 2.1, 2.1 times 2.5. Okay, be careful. We have to use a convention because even 1D motion, we have positive and negative things. So this is minus because this moving to the right, this moving to the left. Okay, so our convention is right is positive, left is negative. Okay, be careful. So you have to minus 4.5 here. Okay, so let's the total momentum before the collision. Okay, so what's the total momentum after the collision? P prime. Okay, actually m1 v1 prime plus m2 v2 prime. Actually, we don't know the answer yet, so actually just 1.6 v1 prime plus 2.1 times v2 prime. Okay, and then we will have equation. We'll have equation, and let's give this a value. Okay, so we need to we need to engineer calculators. Engineer calculators. 2.4 minus 2.1 times 2.5. Oh, okay, 1.15. So we will have equation like this: 1.6 v1 prime plus 2.1 v2 prime equal to 1.15. Okay, this is our equation one. Okay. So right now we only have one equation, but we want to solve the v1 prime and v2 prime. Yeah, we want to find a velocity after the collision. So v1 prime, v2 prime, we have to solve. But right now we have two unknowns, but only one equation. So it's not solvable. So we need another equation. So I will pick up this one: v1 minus v2 equal to v2 prime minus v1 prime. So okay, so let's see. V1 minus V2 equal to V2 prime minus V1 prime. What is V1? It's 4, right? So be careful. 4 and minus V2 prime. Okay, be careful. It's minus 2.5. Minus 2.5. Okay. And equal to V2 prime minus V1 prime. Okay, so we will have another equation. Okay, that makes the metric we have a minus v1 prime plus v2 prime equal to 6.5. That's our second equation. Okay, right now we have one equation and two equation. Okay, and two unknowns. So we can solve this. We can solve this out. So I'm not going to show the detail of solve this system equation because it's very easy to use. Okay, just give you an answers. What's the answers? Yeah, the answer should be okay. V1 prime equal to 3.38 meter per second. But it has a negative sign. Let's moving to the left direction. And v2 prime is equal to 3.12 meter per second. Okay, so that's the velocity after the velocity after the elastic collision. Okay, so here is the we answer the first problem. Okay, so next problem is okay. You want to calculate at the intermediate state. So that's during the collision. You want to try to find the compression value at a certain intermediate state because these two objects will collide to each other, and when they collide to each other, the spring will compress. Okay, and at a certain intermediate state, the velocity of m1 becomes to 3 meters per second. At this particular intermediate state, what's the compression value of the spring? Okay, and I think I will do this second problem in the next video. Okay, because because if you continue do this, maybe that's will too long. The video will too long. Okay, so I will start the video yeah, I'll start video here, and we'll see you in the next part. Okay, thank you. Bye bye. Okay, really try to solve by yourself. Okay, that is easier to solve. Okay, okay, that's me.